Welcome to the SkillTorch Disrupt Podcast, where we dive into the world of innovation and technology. My name is Melica, and I'm the founder and director of SkillTorch, which is a recruitment company focusing on the AI and the rest of the tech space globally. Today, I have with me Jason, who is the co-founder and the VP of the VP of ML at OctoML. He's joining us to really dive deep into the subject of generative AI and why we should all be using it. So, Jason, I'll give the floor to you. It'd be great if you can introduce the audience about who you are and your background and what you're about.
Yeah, so I started my career in this space, really traveling after the biomedical space. Wanted to do more with cancer biology and develop new drugs and new diagnostics. And I happened to find myself in a graduate program doing machine learning, what I learned at the time, in order to understand the complex dynamics between cells and their gene regulatory networks and to try and make sense of the complex organisms and systems that underlie biology. And I took that and did a stint in biotech, but found we needed more powerful machine learning and machine learning infrastructure. So I joined a startup doing deep learning hardware. It was one of the first deep learning hardware companies that was acquired by Intel, and I led a software product there and saw a lot of what the challenges and needs were in the space in the ML infrastructure area. And that led to me meeting a number of amazing folks, including the other co-founders of OctoML, where we're now making it easier to build AI-powered applications at scale.
Oh, fantastic. And what kind of drove you guys? I know you've already touched on this just now, but I mean, that's quite a transition from going from cancer and biology to actually like pure AI ML tech. So how was that?
Yeah, it's funny you ask because Luis, the CEO and co-founder of OctoML, he also had he had two research thrusts at University of Washington. One was the compilation of efficient machine learning code to make machine learning more cost effective and low latency, but also a digital microfluidics biology laboratory applying kind of architectural computer architecture techniques to the study of biology and DNA synthesis. And so we hit it off immediately. And but the needs for machine learning are just so great, and so kind of the first step in the stepping stone to really solving complex systems diseases. That's why we decided to start OctoML, because frankly, we just saw the rise in needs in compute and the complexity of that compute continue to increase. And the number of hardware and the complexity of that hardware was a great fit for what Luis and Tianchi, Jared and Terry were doing in the laboratory. And it was a very natural fit to then commercialize that. And initially we started with approaching very sophisticated ML engineering teams and telling them, hey, you're running machine learning at scale, and we can help you to reduce the cost and lower latencies. And so that was a very natural motion. We worked with great partners at companies like Microsoft and Qualcomm, helping them. But then the generative AI kind of explosion happened, and we realized that we could be helping a whole new wave of developers to leverage these powerful techniques, and only getting more powerful, but offer the same benefits of easy to use, low cost, and low latency. And so that's where we're focused today, is really building an infrastructure platform for all developers to be able to leverage these generative AI capabilities that we can get more into.
Right. That's really interesting, insight and story there about your journey. Really applaud you for that, especially just starting off in terms of like life changing, research and treatment like cancer. I think that's amazing. Just going into the topic of generative AI for our listeners that are just new to AI and just exploring it, trying out ChatGPT, could you maybe just give an overview of actually what generative AI is?
Yeah, so in the early days of machine learning, depending on where you want to, how far you want to look back, the the core of machine learning is to, instead of telling a computer explicitly what to do, like by programming it, you instead give it examples and use math to kind of find an algorithm that does the task that you want. And this, the machine learning started, or at least statistical machine learning, doing this on rather simple tasks like classification, where you pass it an input and ask it a question, kind of yes or no, or dog or cat. Is this an image of a dog or a cat? Or, it was actually not images. Images came along much later as a much more complex problem. But still, the output task was rather simple of yes, no, or maybe choose from this set of 5 options. And this is called discriminative machine learning. Generative machine learning is where you expand that to instead say, instead of making a decision about the input I'm giving you, I want you to actually sample from a space of this complex probability space. And so instead of passing in an image and asking it, is this a cat or a dog or one of these 100 classes, you're instead saying, essentially, give me a new image of a cat or a dog. And if you kind of torture the definition, you can think of for each pixel you're trying to pick a value of that pixel, red, green, and blue. But really, they're such different problems that we typically categorize them separately. And so generative AI is you're trying to sample from these large distributions of images or sounds or text. And while they share a lot in common with their previous discriminative types of machine learning, because the domains are so large in terms of the size of the sample space that you're sampling from, you really consider using different techniques. And so while and really I think what's been so surprising in the generative AI space is that the techniques have progressed so quickly. So initially, variational autoencoders or generative adversarial networks, VAs and GANs, kind of both were very monumental and transformative in terms of what they could do in terms of generating images. I think if you showed anyone images from those models today, they would say, "Wow, okay, that doesn't look very useful." But the progress between and kind of the time between these new techniques was really surprising. And then you have diffusion models and large language models then that have come out most recently, where the quality has really just been tremendously improved, and really an entire industry has of research and commercialization has opened up around these. So that's that's helpful for a quick background on generative AI.
Yeah, no, thanks for sharing that and just providing us with that overview. So talking about LLMs, which stands for obviously large language models. So how would you sort of distinguish that from, previous ML techniques that have, been developed in the past?
Yeah, so large language models, again, it's kind of this blurring of the line between discriminative AI and or machine learning. And I use AI and machine learning interchangeably because all significant AI techniques these days are essentially machine learning or statistical machine learning techniques when you boil it down. And so what an LLM is doing is essentially taking a set of text as input, not always text, but it usually is, and then actually predicting what the next value of what the next word, if you will, of text is based on the previous set of text that it's seen. So it's actually doing a classification task, but it does that so well. And when you run it in a loop to generate multiple words in a row, it then effectively samples from a distribution of all possible text. And so we call it a generative AI model. And they work so well and are so versatile that we can get into that they really are their own entire class of capability. And they're starting to mix and match with other techniques of, oh, well, what if you want to pass in an image and some text at the same time, or generate an image with your text? And so then you get in the world of multimodal generative AI, where you're talking about multiple modalities of text and image and audio, etc.
Okay. Well, I mean,
And I think
again,
another thing that,
yeah.
just to add a little bit more, sorry, I forgot to add a piece here, is one of the things that separates LMs from previous techniques is the incredible amount of training data that's used to
Okay.
train these models. And, you have on the order, a token is close to a word. There's a slight difference there, but you can think of them similarly. And the number of tokens used to train the modern, common large language models is, up to 10 trillion tokens of
Oh,
input
wow.
text, which is basically the entire internet plus some, depending on how you're counting. And then the amount of compute required, both within a single run of the model and across that entire training run, is just truly incredible. And what's driven this actually is something called these scaling laws for large language models. And this has kind of enabled us to uh, predict with relatively high accuracy of, okay, well, if you put one chunk of training data into training an LLM, and you get a result that's X good quality, and we'll get into evaluation, I hope, in a bit. But if you put in two chunks of training data, then you can predict actually quite accurately what the improvement of that model is going to be with that doubling of training data. And so this is kind of enabled teams to go out and spend large amounts of money on acquiring training data and compute, because they can predict with relatively good accuracy how the model is going to improve over time before they ever do the experiment. So these scaling laws have really, I think, encouraged, similarly to Moore's law, actually, of just kind of giving people a sense of what's possible, and kind of thinking ahead, and being bold to try experiments in relatively costly or very costly endeavors.
Wow. Yeah, I mean, just talking about the LLMs and evaluating that. So obviously, from what I've heard and what I've read, it can be challenging. What are the sort of common approaches to it, and why may they be sort of insufficient?
Yeah, so one of the most basic measures of an LLM's quality is called perplexity, which is where for every time you generate a word, the model has some score of how likely it thinks that word is versus all the other words. And by comparing the model's expected probability of what that word is versus what the actual word was in your training set, then you can compare that and compute a score called perplexity over many words, that gives you a sense for, like, on average, how close was this model to producing the actual text that was observed in the training data. Um, and so you can do this in a whole bunch of techniques around this to kind of get a sense for how close the model is to either a known piece of text that you train the model on, or that or that a new set of text that you want the model to produce under a new circumstance. So that's kind of the most basic, but typically, that's not a great measure for how the models actually perform in practice on a given task. And so then you have kind of downstream tasks, which are you give the model a multiple choice question, and you have it generate A, B, C, or D, and or you have it do a set of machine translation from one language to another, or summarization from a large piece of input text to a smaller piece of text. And there are various ways of computing quantitative scores for these. Some are easier than others, but in general, I think the difficulty with these is, on the multiple choice question and answer, for example, I think as these models become more capable and more powerful and general purpose, it becomes a bit more akin to how we think about people when we hire them for a task, for like a contractor or an employee. And because while these scores, like an SAT score or an LSAT, can be helpful to give you a sense of what someone's ability to study and practice for a test is, if you will. It doesn't necessarily tell you much about how they'll react in a novel circumstance for a new problem that you're interested in. And so I think this is more and more becoming the case with LLMs as well, because these are very general purpose, language models that have been trained on essentially the entire internet and memorized a good chunk of it, which that's a whole other story of talking about memorization of the training set and some of the data there that's interesting. But what you care about ultimately at the end of the day is how well this model works for your task that's of importance to you. And typically that's not what people are reporting in the literature, because how could they? Right? That's your task with your data in your context, and so that's why it's so important to do your own testing and validation and customization that we can get into more.
Right. Okay. Well, I mean, when companies are sort of considering LLMs for specific tasks and projects, what should they be considering around that?
Yeah, so I think there's the obvious ones of that we haven't touched on yet, but are cost and latency. So how much is it going to cost if you need to run a trillion tokens or words through this model every week? Like what is that cost outlay going to look like? And also importantly is if a user is interacting with your application, then these LLMs, is that going to add latency to the user's, task or output? And is that a sustainable amount of latency? If they're sitting there waiting for 200 milliseconds, that's probably okay. But if it's, 6 seconds or 15 seconds, then, that's often not sustainable in an interactive application. So cost and latency are critically important. And we've spent a lot of time optimizing that on the OctoML side. Then there's the quality evaluation, which is what we were talking about previously, which is for the given task you're looking at, and not even the broad the most broad like summarization. It's summarization for your type of data, or in particular, what kind of summarization are you looking for? Is it are you trying to pull out specific facts and bring those to the front? Or are you trying to give someone a gist of what's happening in a paragraph? Or are you trying to extract out actionable insights? Right? Those all three are summarization tasks, but they're all different types of summarization, so you would want to measure them differently. And so that is why it's so important to do your own evaluations, and why and frankly, the space is still quite new on this in terms of the best techniques. And so I think still we're in a state where people are doing kind of finger in the air testing of just like, does this look right to me? Of course, you can do better than that, but I think that's where a lot of people are today. And this is why it's so important to look at different models as well, because just like we were talking about, different people have different skill sets and are good at one task versus another. LLMs are the same in that depending on how they were trained and what trade-offs were made and the creation and kind of selection of parameters that describe these models, that it creates very different models. And so that is why it's important for you to check against not only for your data set, but against all these other models as well.
Right. Okay. Well, I mean, targeting sort of companies and businesses, how would you sort of recommend they approach implementing and testing models effectively? And perhaps, what model should they even be considering? Like, what are the choices?
Yeah, I think the kind of framing that I've heard of that I think makes the most sense in this day and age is evaluation driven development. Is
Okay.
start by setting up your evaluation, and then that enables you to then determine if this is working at all, right? Because it's easy to get up and started and say, wow, this is working, and kind of fool yourself into thinking it's working when in actuality it's not. So you have to start with the evaluation in mind. What's great about doing it that way is that once you do that, it's really easy to get to the right cost and latency metrics, because while OpenAI might give you a good starting point, and often is where people start building these LLM powered applications, oftentimes the latency variability and the cost will be higher than what they can sustain in practice, especially as they scale. And so ideally you've had your evaluation set up from the beginning and you're constantly improving it. And so then once you're ready to move to a more cost effective and latency, low latency provider, then you're able to just hook that evaluation harness up to testing against open source models that enable you to control your own destiny of where you're hosting these models, where they're going to go, kind of the rate of update. All these things are out of your control when you're using a proprietary LLM provider. But when you're using open source based models, you then have much more flexibility in terms of which model, when you upgrade, what trade-offs you want to make, what customizations you have. And you have a wider swath of performance and cost options available to you. And all that starts and is easy to do if you started with that evaluation-based framework, like in a test evaluation-driven development methodology.
Right. Okay. So what about sort of like the individuality of LLMs and like looking at how customizing that is really important and sort of tuning that to specific projects?
Right. So yeah, I've mentioned that, like in that summarization example, there are many
Yeah.
types of summarization. But even inside of a subtype of summarization, let's say you want to extract key facts. Well,
Mhm.
if you are working with legal documents, that's going to be a very different summarization, or what key facts matter versus if you're doing the construction bylaws, or something like a role-playing game, or a rule set, or postings for job descriptions, right? All these have very different notions of what a key point actually is. And so while you can typically get some of the way there by what's called in context learning, or by providing examples in the prompt, and
Yeah.
then passing those to a model, proprietary model upstream, you can get a lot more control by getting a few hundred or low thousands of examples together through a variety of techniques, and then fine tuning your model to pull out the type of summarization that you want for the type of data set, and based on your customers' feedback. And so that's the real holy grail, if you will, of LLM customization, is doing this fine tuning for your subtask and your type of data, and it gives you much more control over the accuracy of the resulting output, and you can continue to refine that over time based on data drift or new requirements from customers, and you can even customize per your customer. So even within a subtask and a type of data, then your customer might have their own specific subset, and so that gives you another lever of customization and value add that you can provide to your customers.
Okay, very cool. So going back into the generative AI subject overall in the ecosystem. So you mentioned OpenAI. We haven't mentioned Hugging Face yet, but that's just one example I can think of. So talking about the generative AI ecosystem with the likes of OpenAI and also maybe Hugging Face and another one, what do you think's needed to sort of bridge that gap around generative AI?
Yeah, what we've seen is that, like I mentioned, OpenAI is kind of one end of the spectrum of
Mm,
a very small number of models, on the two essentially, and you're supposed to use those general purpose models for all of your needs. And their website clearly kind of describes this, and like, oh, you want to do this task? Use the same model. You want to do this task? Use the same model, and it's just different prompts that kind of steer the model one way or the other. On the other side, you have something like Hugging Face, where you have an enormous repository, a model zoo of probably thousands, if not tens of thousands, of LLMs that the world has uploaded and allows you to use for free. But how do you determine if a given model is good for you based on your use case, like we've talked about, and in particular, the kind of complexities of taking these models and then going to production with them. There's a whole set of other challenges that we haven't talked about, like scaling and rolling upgrades and these kinds of things. And that's where OctoML is well situated, is to kind of fit between these two of, okay, well, we want to help you with your set of models in a tailored, curated set of the best open source models and give you the best cost and performance, so that you have the range of best models to kind of start off the shelf with, and then the ability to customize and scale and run these at large productions for complex environments that neither OpenAI or Hugging Face is going to kind of provide to you with either their very small set of proprietary models that kind of get you reduce the flexibility that you have and the control over your own serving destiny, and then Hugging Face is not going to scale with you and provide the complexities of all of the at scale production infrastructure that you're going to need. So yeah, that's where we fit in the space, and where we're really excited to be working with partners at large scale going forward.
Amazing. Well, I mean, how do you sort of envision the future of generative AI platforms in terms of, I mean, customization and accessibility? I mean, I think the obvious answer is obviously what you guys do, but is there anything else that you can add to that as well?
Yeah, I mean, we definitely, while I talk about scale, really it's about scaling with your needs.
Yeah.
And so we've designed the platform to be easy to use and easy to get started with. And with the consumption-based pricing, it's incredibly low price to get started and build your applications and test, and even run full production applications with very low overhead. But once you hit that product market fit and you need to scale, then that's where we're here to help customize both the serving infrastructure and help you scale and customize your models towards your applications. And it's you have to meet developers where they are and where they're starting, and it can't be an enterprise-driven motion or anything like that. So we've built a platform that's easy to use, well documented, very low cost. $10 a starting credit that these days buys you so much, because it's cents per million tokens of LLM generation, and so $10 goes a long way. You could probably run quite a and again, this is because we're trying to reach to developers building applications. It's people aren't going to want to sit through a form or a intake process that's painful. So we want to get people up and started right away.
Fantastic. Well, I mean, I always ask these kind of future AI questions to everyone on the podcast, but in your perspective, how do you see the future of generative AI, and what should businesses be prepared for, and actually individuals like ourselves, what should we be prepared for?
Yeah, I think on the product builder side, developer side, I think it's clearer than ever that AI is just another tool in the toolbox that every developer needs to have at their disposal. Just like databases were a new thing back in the 80s and 90s, and it was very bespoke, oh yeah, wow, you have a database, right? Whereas now everyone has a database, and it's just assumed that you know how to use that for building your web application. In the same way that AI is just going to be another assumed portion of your application, and I think a lot of people see the AI native applications that are purely driven around the AI component and wouldn't be possible otherwise. But I think you can't miss the other majority of applications which are going to be kind of the same as they always were, but with AI added in as a critical but secondary component that helps drive the flow. So that's on the builder side. On the kind of macro and technologist side, I think the the trend there is okay. Well, what happens when you have small teams of developers or even single developers able to do more and more, and I think it's just going to increase the amount of innovation of small apps and developers and what they're able to do, and what that means for the industry. I don't know. It's hard to tell if it's just going to be another kind of increase in degree or actually induce some kind of phase shift and change in kind that I'm not smart enough and don't have my crystal ball calibrated enough to tell.
You are
So
smart.
so it's going to be very interesting, that's for sure. And probably the last prediction I'll make is that we're going to underestimate the change in
Yeah.
the short period, or sorry, underestimate it in the long term, but overestimate the short term. So I think it's going to get really wild here in 2 to 5 years.
See what happens.
Yeah,
Yeah. Well,
it's a
thank you
fun
so much,
space.
Jason, for joining in. I mean, is there anything else that you sort of wanted to add here? But I mean, overall, it's just been really insightful conversation.
Yeah, I mean, if you're looking to build AI powered apps, then definitely check our platform out at OctoML .ai and check out our platform and see what the amazing things you can do with the both the image generation and text generation side. Because we talked mostly on the text side, but the image side is just as crazy, if not more so, because it's had longer to develop and mature.
Great. Well, thank you so much, Jason. Great to have you on the podcast today. And see you
Yeah, thanks so
soon.
much, Malika. Appreciate it.
Thank you. Take care.
Okay, take care. Bye.